In this video, we're going to be factoring trinomials. Now, by trinomials, we're talking about polynomials with three terms. Now, when we're factoring, it's kind of like we're unmultiplying. So let's review multiplying as it pertains to this situation. All right, let's say we wanted to multiply x plus 4 times x plus 2. Now, we're not factoring yet, we're multiplying. Remember, factoring is like unmultiplying. But when we're multiplying, in this case, we would multiply the x times both terms in the other binomial, and then we'd multiply 4 times both terms in the other binomial. And when we do those four little multiplication problems, we'd end up with x squared plus 2x plus 4x plus 8. Now we notice there's some like terms here, so let's go ahead and combine those. And we get our product. Now factoring is the opposite of this process. So now let's say we're factoring. We'd be starting with something like x squared plus 6x plus 8. And when we factor it, we're going to break it down into its factors. Or in this case, two binomials that multiply to make the original trinomial. So here we multiplied x plus 4 times x plus 2 and got x squared plus 6x plus 8. Here we're factoring the same thing that we got when we multiplied. And when we factored it, we got these two binomials, which is what we started with here. So we have a very close relationship between multiplying and factoring. They're just going in different directions. Now, why do we want to factor? Well, a couple of things is factoring will help us graph quadratic equations. So if we are graphing the equation y equals x squared plus 6x plus 8, these factors actually give us clues as to what the graph looks like. In particular, it helps us find the x-intercepts, which give us a rough idea of what the parabola will look like for that particular quadratic equation. Factoring can also help us solve quadratic equations. So if we're solving the equation x squared plus 6x plus 8 is equal to 0, these factors would help us figure out that the solutions are x equals negative 4 and x equals negative 2. So lots going on with factoring. Let's dive in. Now, when we factor a trinomial like this, we usually are trying to figure out what two binomials would multiply to make this trinomial, if any. Now let's think about this for a minute. If we had two binomials and we were multiplying them and we needed to have a p squared like this, well, that means that we would start by multiplying p times p. And that would give us the p squared. Now, when we multiply these last two terms, we need to end up getting 24. Well, let's think about numbers that multiply to make 24. Let's see, we have 2 times 12. In fact, let's go ahead and try that. So if we did p plus 2 times p plus 12, if we multiplied this out with the 4 multiplication problems, let's see what we get. Well, we have the p squared and we have the 24, but when we combine these like terms, we don't get 11, we get 14. So these aren't the right factors. But notice what we're doing here. So we had these two numbers that were factors of 24, 2 and 12. And when we multiply those, we get 24. And when we add them, we end up getting 14. But we want our two factors to add to 11. Okay, back to the drawing board. So we already tried 2 times 12. Let's try 3 times 8. So we could have a factor of p plus 3 and a factor of p plus 8. When we multiply those out, p times p, p times 8, 3 times p, and 3 times 8. Now when we combine these like terms, we do get 11p. So these are the factors. I'm going to erase this part because that's not the answer. That was the question that we started with. So we successfully factored our trinomial into these two binomials. All right, once again, we're factoring a trinomial, and we're going to try to break it down into two binomials. Now, to get the b squared, that has to be b times b. Now, just like in the last one, we want these last two numbers to multiply to make 16, but then they have to add up to 10, those same two numbers, because when we combine like terms, we're adding, and we need to get 10b. Okay, I'm going to introduce a tool we can use to help us organize our thinking on this. Now, I made this little X, and it's just a diagram to help organize my thoughts. I want two numbers that multiply to make 16. And I want those same two numbers to have a sum of 10. So I just put the product we want on the top and the sum we want on the bottom. Okay, so I have everything displayed here, and I'm trying to think of two numbers that not only have a product of 16, but also have a sum of 10. Well, 8 times 2 is 16, and 8 plus 2 equals 10. So our factors are b plus 8 times b plus 2. Now, we could check that by multiplying these two binomials together, do the four little multiplication problems, and we'd end up with our original expression. Number 3, once again, we are factoring a trinomial. To get x squared, we know it will be x times x. Now, we want two numbers that multiply to make negative 40. Those same two numbers need to have a sum of negative 3. So now we're dealing with negative numbers. Okay, let's write out some numbers that multiply to make 40. Well, we know that 8 times 5 equals 40, and we need one of those numbers to be negative so that the product is negative. Now, notice when we combine like terms, we're going to have a negative number there. So that means the larger number needs to be negative, because when you add two numbers and one is positive and one is negative, we use the sign of the larger number. Okay, so let's take a look here. Well, negative 8 times 5 does equal negative 40. And when we add these two numbers together, we get negative 3. So these are the two numbers that we need. Now, this little X diagram, some people call it a diamond problem, is not the answer. It's just a tool to help us organize our thoughts so that we can get our factors. All right, so our two factors are x minus 8 times x plus 5. And don't forget, when we're factoring, we are just unmultiplying. Right, now we're factoring x squared plus 9x minus 10. To get to x squared, we know it has to be x times x. And to figure out these last two numbers, well, we're trying to think of two numbers that have a product of negative 10 and a sum of positive 9. All right, to have a product of a negative number, we need one number to be negative and one number to be positive. In this case, the sum is positive, so the larger number will need to be positive. Well, let's see. To get 10, we could do 5 times 2. In this case, we want the larger number to be positive because the sum is positive, so that would have to be 5 times negative 2, but that doesn't have a sum of 9. They do have a product of negative 10, but we won't have a middle term of 9x here. That doesn't work. Let's think of two other numbers that multiply to make negative 10. Well, we don't want to forget 10 times 1. In this case, it would be 10 times negative 1, because remember, our sum is positive. So 10 times negative 1 does equal negative 10, and it has a sum of positive 9. All right, found it. So we have 10 times negative 1 equals negative 10. 10 plus negative 1 does equal 9. So when we combine our like terms after doing the four multiplication problems, we would get 9x in this case. All right, so we have x plus 10 times x minus 1. So these wing numbers here help us fill in our two factors. So here we're factoring. N times n will give us n squared. We need two numbers that multiply to make positive 20. And those same two numbers need to have a sum of negative 9. All right, 10 times 2 is 20. Let's see, notice here we have a negative sum. Well, let's see, these do multiply to make positive 20, but there's no way we're going to get a sum of negative 9 out of these two positive numbers. So we think for a moment and realize there's another way to get a positive product, and that's when we multiply two negative numbers. So we have negative 10 times negative 2 does equal positive 20, and it has a sum that's negative. Now, in this case, the sum does not equal negative 9. It equals negative 12. So these aren't the ones. So let's think of two other numbers that multiply to make positive 20. They're both going to be negative. Let's see, 4 times 5 equals 20. So negative 4 times negative 5 does equal positive 20. And those two numbers have a sum of negative 9. All right, so these wing numbers here will help us get our factors. So we have n minus 4 times n minus 5. Now don't forget the big picture here. If we were to multiply these two binomials, we'd have four little multiplication problems to do, and they would equal n squared minus 9n plus 20. So we're just unmultiplying when we're factoring. All right, here we have b times b will give us b squared. And we need two numbers that multiply to make 18, and they need to have a sum of negative 9. So let's think of numbers that multiply to make 18. 9 times 2. Now, once again, we need a positive product, but a negative sum. There's no way we're going to get two positive numbers to add up to a negative number. So once again, this is where we multiply two negative numbers to get a positive. And those will have a negative sum. But these add up to negative 11, not negative 9, like we wanted. So those aren't the ones. But negative 6 times negative 3, those have a sum of negative 9, and they also have a product of 18. So we found our two wing numbers here. So our factors are b minus 6 times b minus 3. X times x equals x squared. We need two numbers that multiply to make positive 10 with a sum of negative 11. Well, we knew 5 times 2 equals 10. Once again, positive product, negative sum. So we'll have negative times negative is positive, but these don't add up to negative 11. They add up to negative 10, so it can't be those. Let's not forget about multiplying by 1. Negative 10 times negative 1 is positive 10, and these do have a sum of negative 11. So our factors are x minus 10 times x minus 1. Well, m times m equals m squared. And we need two numbers that multiply to make negative 56. In this case, we understand there's a coefficient of 1 in front of that m. So these two numbers that multiply to negative 56 must have a sum of negative 1. All right, multiplying 8 times 7 gives us 56. We need negative 56. Now the larger number in this case will be negative, so that when we add the two numbers, we get a negative number. Well, negative 8 times 7 is negative 56, and these do have a sum of negative 1, so we got it. So we have negative 8 times 7. So we get m minus 8 times m plus 7. Now, as you get better at these, you may be able to factor without the help of a diamond problem. So for instance here, We have x times x is x squared. And then to get this 16, well, let's see here. 8 times 2 is 16, but those have a sum of 10, so that's not going to work. But 4 times 4 equals 16, and those have a sum of 8. Now, this one, we notice, is somewhat special because the two binomials are the same. So another way to write that, which would be preferred, would be x plus 4 squared. Now, that means there's a special name for this trinomial here. It turns out we call this a perfect square trinomial because it has only one distinct factor. Now, the topic of these examples is factoring trinomials when a equals 1, and by that we just mean there's a 1 in front of this. This is not a trinomial, but it's a special kind of binomial that factors exactly like the others. I'm going to take a moment to rewrite this as x squared plus 0x minus 25. So we notice that this one was missing the middle term. So we have x times x is x squared. Now we need to think of two numbers that multiply to make 25 and have a sum of 0. Well, let's see, 5 times 5 equals 25. And we need one of those to be negatives. Let's just choose the first one. And those two numbers have a sum of 0. Negative 5 plus 5 is 0. So our factors are x minus 5 times x plus 5. Now, binomials like this have a special name also. They're called a difference of squares because we started with two perfect squares that we were subtracting. In these examples, all of the trinomials were factorable. That's not always the case. We often have trinomials that are not factorable at all. We can't break them down, and that's fine. I hope these examples have been helpful. This is Mr. Ela, signing off.